Okay, so I don't want to waffle too much, so I'm just going to get straight to it. So over here we have y bracket 0 equals 4 as our initial value here. So as you can see, y bracket 0 equals 4 is a function, just like you might have fx, and then normally fx would equal to y, so it's a bit similar to that. But this time we have y as the function here. We have x given over here, and then we have dy over dx over here as well. So we could assume that we have y bracket x as such. So therefore we know that a coordinate we can make would be when x is 0, we have y as 4, because that's the answer to the function of y there. So that's one thing we could assume, that y is 4 when x is 0. The next step would be to solve this differential equation up here. So we always want to get the same letters on the same side. So we want to get dx onto this side, and then dy we can leave on this side. So to do this, we will do dy equals 6x minus 3, and then we'll just multiply this side by dx. Since the line means divide, so to bring dx to this side, we multiply by dx. Some people say multiply both sides by dx, so that cancels. So the left side will cancel out dx, and then dx will be put here. So that's what we get. And mostly for these, to get back to the original equation, we need to integrate it, because integration is the opposite of differentiation. So we integrate both sides, that's step 3. So of course over here we have dy on its own, but we always have like an invisible one, so it'll be 1 dy equals 6x minus 3 dx. Now we just need to integrate it, which shouldn't be too difficult. So over here, integral of 1 would just be x. Oh, sorry, not x. Because we have it in terms of y, it will just equal to y. And then on this side, the right side, we have 6x, and that will become, for every x, there's a power of 1 there. So every, x that exists on its own has a 1. And just the same thing as every number is to the power of 1, and it just gives itself. So as we have an invisible 1 over here as well, whenever we integrate, we add another 1 to the power, so that will become 6x squared. And then we also have a division sign over here. Let me just draw that out. A division sign. So we divide this whole entire term, you could say, by the power. So we'll put 2 down here. Then for 3 over here, we will have an x added next to it, or multiplied to it, minus 3x. And then don't forget your child, that's how I remember it, plus c. So the reason 3x becomes 3x is because when you have a number over here, and it's in terms of x, as you can see over here, in terms of x. So that means every number in this sort of equation, or this expression, should have an x. But here you don't have an x. That's because the x is invisible. And how is the x invisible? Because the x is to the power of, so the x, I don't know if you can see that. Let me do this one. The x, so we have 3x, but it's to the power 0. And every number to the power 0, let me just write it. So every number to the power of 0 is 1. So knowing that, it will just be 3 times 1, which is 3. And then that's how we get that 3 on its own there. But it's still logically to the power of x. Not power, sorry. Multiplied by x, in terms of x. Okay, so now step 5 is just to simplify. So we have y equals 6 divided by 2 would be 3x squared minus 3x plus c. Sorry, that's supposed to be squared there. And then step 6 we have this constant c, which is unknown, so we need to solve it. How can we solve the constant c? Well, we have two unknowns here, x and y. We will go back to our initial values over here where we have y is 4 when x is 0. So we'll use that to find what c is. So all we have to do is substitute. So y is 4 equals 3, 0 for x squared minus 3, 0 for x and plus c. So these will cancel out to 0 minus 0 plus c equals 4. So the zeros don't really care about them. So that means c equals 4. So therefore our answer would be y equals 3x squared minus 3x plus 4. And that's it. That's your answer. Thank you for watching.